Hey, 8th grade. So our learning target today is I can identify and solve proportionate situations, y equals mx, using graphs. So we're going to use strictly graphs in our work today. You should be on this page, page 17. You can see a lot of our work today is kind of coming from a blank graph because we're going to use specific scenarios. Remember, proportionate means 0, 0, which means then we can take cross products to solve. Okay, so for our work today, we're going to go ahead and look at this first scenario. So you should be in box number 1. So we have Joey eats 60 hot dogs in 12 minutes. How many would he eat in 5 minutes? So we're going to go ahead and say Joey eats 60 hot dogs in 12 minutes. How many hot dogs would he eat in 5 minutes? How many hot dogs in 5 minutes? Go ahead and ignore that phone call, sorry. So we want to know if it's proportionate to start. Is it true that if Joey if we don't start the time at all, then Joey doesn't eat any hot dogs? So no time, no hot dogs, we would say yes. And when that happens, we can go ahead and take cross products. When that happens, cross products. So we could take cross products and solve. So we would go ahead and say, multiply here, we have 12 times x equals multiply here. We have 60 times 5, so we have 60 times 5 gives us 300. We would divide by 12, copy paste, and we would find out that Joey eats 25 hot dogs in 5 minutes using that same relationship. Okay, so before we graph it, we're going to go ahead and watch the Holy Hot Dog. It's Nathan's Hot Dogs. It's a world record. If you want to go ahead and just watch this video, you don't have anything to write right now. Everything came out of that table from cross products and solving. So let's go ahead and watch this. Okay, so you should have this situation. What? So go back to the beginning.
Doing a little bit of it. Now he presses his stomach with his ribcage and
might be, whoops, the most possibly the grossest thing you've ever seen.
We're closing right now on the Nathan's record of 53 3/4. Kurt Schilling damned. Kobayashi is bringing it. He's just 2 hot dogs behind Chestnut right now. We have nearly 4 minutes remaining in this competition. The table enders now not even in focus because the entire world, the entire free world, is focused on these 2 men. There he is, Pat Bertoletti with 39. Still has 3 minutes to go. Bertoletti, as I said, is dedicating this contest to Nikki Hilton because he told me he feels as though Nikki lives.
Okay, so we have. So we have this scenario of this hot dog eating contest right now. So we have this world record that's being set. So that gives you kind of an example of where it's at. So we have minutes and hot dogs. So we have Holy Hot Dog. And in this scenario, we would go ahead and set up a graph. So in our graph, we have already our title called Holy Hot Dog. If you want to watch the whole video on your own later, you can. But I'm going to move on through the lesson. On the y-axis, we know that we have the number of hot dogs. On the x-axis, we have the number of minutes. We have minutes on the x-axis. So and the number of minutes ranges from 0 to 12, as you can see. From 0 to 12. We have 0, 5, and 12 on the x-axis. So we're going to have to go by 2s. We'd say 0, 2, 4, 6, 8, 10, and 12, the number of minutes on it. On the y-axis, we range from 0 to 60. So if we went 5, 10, 15, 20, 25, 30, 35, 40, we're not going to make it. So we need to get from 0 to 60 over here. I'm going to go by 10s, 10, 20, 30, 40, 50, 60. I'm going to give you a chance to get caught up. Go ahead and get caught up there. Okay, so as we start to solve then, we would say in 12 minutes, Joey was able to eat 60 hot dogs, which makes me actually want to throw up. In 5 minutes, Joey ate 25 hot dogs. So we would locate 5 in between here and up to 25 hot dogs. And in 0 minutes, Joey didn't eat any hot dogs. So we have this nice linear graph. So that's kind of the graph of Joey. Sorry about my super crooked line there. Go ahead and graph that out. And now we have some work to do. We need to find the slope as it says. What's the slope of this equation? Now we can get the slope many different ways. We can get it through rise run, which might not be super easy in this problem. Or we can get it from y2 minus y1 over x2 minus x1. I'm going to go ahead and do that as my slope. So some data points that I can use, I'm going to erase this information over here so I have some space to write, is I have an x1 and an x2, and I have a y1 and a y2. So I'm going to use that as my slope work. y2 minus y1 over x2 minus x1. So my y2 value is 25. My y1 value is 60. My x2 value is 5. My x1 value is 12. I stop, chop, chop numerator, I get negative 35. Go ahead and catch up. If I'm going too fast, go ahead and pause that video. I stop, chop, chop denominator, I have negative 7. So my slope then is 5. So I have 5 hot dogs per minute. So let's go ahead and make sure we write that out. 5 hot dogs per minute is my slope. So my equation is in the form of y equals mx plus b. B is the beginning amount of hot dogs eaten. Well, at the very beginning, Joey has eaten 0 hot dogs. And we know the slope is 5 hot dogs per minute. So my equation really ends up being y equals 5x. I'm going to drop off that plus 0 because it really doesn't change anything. But there's my slope and there's my equation for the Joey hot dog scenario. Go ahead and catch up if I went too fast there, and then we're going to move on. Go ahead and pause the video if you need to. Moving on pretty soon here. Okay. All right, so we'll skip that check step for right now because I don't want to overteach it, but there's our first scenario. So let's go to the next scenario, box number 2. In box number 2, he can wrap 80 syllables in 4 seconds. How many can he do in 1 minute? So we have 80 syllables. So we put 80 by the syllables, and we have 4 seconds. We put 4 by the seconds. How many can he do in 1 minute? So where am I going to put the 1? I don't have anywhere to put it. We know that 1 minute is the same as 60 seconds. So we could say 60 seconds, how many syllables can he wrap? Wanting to know what happens at 0, 0. Is it true if the time hasn't started, he hasn't wrapped it at all? Yes, that's true. And because that's true, we can take cross products to get our answer. So cross products to get our answer, we would grab our variable and multiply across. We get 4x equals, we would multiply across here, 60 times 80 is 4,800. Go ahead and catch up if I'm going too fast. Go ahead and catch up if I'm going too fast. Divide by 4, copy and paste, and we get x equals 1,200 syllables. So you can wrap 1,200 syllables in 60 seconds or 1 minute. Go ahead and catch up. I'm going to take some notes at the same time. Okay, as we start to solve them, we have x1, x2, y1, y2, finding the slope down below. So we have y2 is 1,200 minus my y1 is 80. My x2 is 60. My x1 is 4. So as I start to solve then, I have 1,200 minus 80 in the numerator. So we have 1,200 minus 80 in the numerator, which is 1120. In the denominator, I have 56, which gives us 20 as our slope. Our slope is 20 then. Slope is 20 syllables per second. That's our slope. So for our equation then, we have y equals mx plus b. And what we know here is that the slope is 20. So we have y equals 20 syllables per second. And we start at 0. So we go ahead and drop off that plus 0 because it doesn't affect the problem at all. But there's my equation, y equals 20x. And we still have to graph this information. All right, so we're going to skip that check. We're going to graph it. Now, I already accidentally have this graphed for you. I might delete that. All right, so here we go. We are talking about the fastest wrapper. That's a perfect title. Let's go ahead and write that down, guys. And this fastest wrapper, the y-axis is already labeled for us. It's the syllables. How fast can he wrap? And the x-axis is the seconds. X-axis is the seconds. Our seconds range from 0 to 60. So I'm actually going to go by tens on my x-axis. So 10, 20, 30, 40, 50, 60 in measurement in seconds. Go ahead and catch up there. And our syllables range from 0 to 1,200. So I can't go by 100s, but I could go by 200. So we could say 200, 400, 600, 800, 1,000, 1,200. That will fit on the graph. There's probably another way we could have done it, but that's what I'm going to go with. So I went by 200s. Like we could have went by 150s perhaps. I'm just going to try to keep it as simple as possible right now through the video. In class, we could have a conversation about what to pick instead, but it's kind of hard to do through the video. So we would say 480. So we're going to go right 4 seconds up 80. Total guessing game here is kind of somewhere in this box, 480. We're going to say right 60 up 1,200. Right 60 up 1,200. And then, of course, we have 0, 0. So we have this nice line that represents the rate in which the wrapper is getting those syllables out. Okay, so moving on, we have one more problem for today. Next problem for today, Bob made 42 free throws in 60 seconds. So Bob makes 42 free throws in 60 seconds. How many free throws does Bob make in 10 seconds? Go ahead and get that set up. So Bob makes 60. So how many free throws does Bob make? So in 60 seconds, Bob makes 42. How would Bob do in 10 seconds? All right, so let's ask the question of does it go through 0, 0? So if the time hasn't started, is it proportionate? Has Bob shot any free throws? No. So we would say yes, proportionate, which means we can take cross products and solving. So we get 60x equals 420. Hand method kicks in, divide by 60, copy, paste. We get x equals 7. So we're going to say that Bob makes 7 free throws in 10 seconds. Go ahead and catch up if you didn't get that. Go ahead and catch up. Okay, so let's go ahead and grab that slope then. So I'm going to grab the slope right from this table. So for my table, I have x1, x2, y1, y2. So our slope then is 7 minus 42, y2 minus y1, over x2 minus x1. So as I start to solve, then we have 42, or 7 minus 42, it's going to be a negative number. Gives me negative 35 over negative 50. So we can divide top and bottom by 5, gives me negative 7 over 10, negative 7 tenths. So I'm going to put that in a decimal form, which is negative 7 tenths. It's actually positive, sorry guys. positive, there's two negatives here, so positive 7/10. So what we're really saying is that his slope, kind of crazy, is he can make 7/10 of a free throw per minute, which seems kind of weird because, like, how can you make part of a free throw? But that's the speed at which he's shooting, which means he's shooting at that rate. So the equation then would be y equals mx plus b. Now you know he's starting at 0 because if the clock hasn't started, he hasn't shot any free throws. The speed at which he's shooting is 0.7 per free throw. So there's our equation. Of course, we can drop off that plus 0 at the end because it doesn't change the problem anymore. All right, so for the graph then, we have the fastest free thrower, world record competition. And in this work, we would say that we have the number of seconds down here. Over here, we would say the number of free throws. Okay, so we have seconds and free throws, and our seconds range from 0 to 60. So I think I'll go by tens again. 10, 20, 30, 40, 50, 60 seconds. So 10, 20, go ahead and catch up on that. Okay, so our free throws range from 0 to 42. So I think I might even go by sevens because that's kind of our range. So 7, 14, 21, 28. I'm just going by the numbers that I see here, the pattern that's there. 35, 42. Okay, planning those out then. So 60 seconds is 42 free throws. 10 seconds is 7 free throws. And 0 seconds is 0 free throws. So we have this nice linear graph there. Plot those out. Go ahead and catch up if that was too fast. I used 7 as my slope or as my scale over there just because I saw a couple of those data points that are factors that are divisible by 7. Okay, guys, so that kind of wraps up our lesson for today. Everything we did today is about whether something's proportionate and how to graph it. So everything we're doing in our learning target today is about graphs. We're going to skip that problem here. So remember, all proportionate graphs start at 0, 0. If they are proportionate, you can take cross products. Okay, so that's our graph work. If it starts at 0, 0, you can take cross products to get information. Remember, to get the slope, we can go y2 minus y1 divided by x2 minus x1, or you can rise run it. Sometimes rise running on graphs, it's a little bit tricky, especially if the scales are off a little bit. Your homework for tonight is to do page 18. Have a fabulous